In this lesson, we are going to learn about a constant called solubility product constant KSP. In a saturated solution of a slightly soluble salt, for example, calcium phosphate, an equilibrium exists between the undissolved solid salt and its dissolved ions. An expression for KSP, or the solubility product constant, is the product of the molar concentrations of the ions involved in the equilibrium, each raised to the power of its stoichiometric coefficient in the equilibrium equation. The KSP indicates how soluble the solid is in water. It's a quantitative measure of the solubility of a slightly soluble salt. As you can see from the table, is given the solubility product constants KSP for various salts. A higher KSP indicates a higher solubility and a lower KSP indicates a lower solubility. Let us compare the solubility of cobalt-2 carbonate, which has the KSP value of 1 times 10 to the power of negative 10, and zinc iodate with the KSP value of 3.9 times 10 to the power of negative 6. Zinc iodate will have a higher solubility than cobalt-2 carbonate. A soluble ionic compound which dissolves 100% in water, such as sodium chloride, do not have KSP values. Generally, solutions can be divided into 3 types. A saturated solution, a solution in which the undissolved solute and dissolved solute or ions are in equilibrium. And we have an unsaturated solution, where it is a solution containing less solute than a saturated solution. Thirdly, we have a supersaturated solution, where a solution containing more solute than an equivalent saturated solution. We are going to learn about the common ion effect. What is a common ion? A common ion is an ion that is common to 2 or more components in a mixture of a solution of ions. A common ion shifts an equilibrium and also reduces the solubility of a salt. Let us look at an example of how the presence of a common ion will affect an equilibrium and decrease the solubility of a slightly soluble ionic compound or the salt. For example, the addition of sodium chromate, a soluble salt, to the saturated solution of the slightly soluble salt of lead chromate. The equation for the saturated solution of lead chromate is seen here. When sodium chromate is added to the solution, you can notice that there is a common ion present. It is the chromate ion. The effect of adding the common ion, which is the chromate ion, will increase the concentration of chromate ion. Therefore, the equilibrium is disturbed according to Lee-Chatelier principle. Therefore, the equilibrium shifts to the left, where the chromate ions will combine with the lead ions to form solid lead chromate. In this way, the solubility of lead chromate decreases. This is how a common ion decreases the solubility of a slightly soluble ionic compound or the salt.